All right, we're good to go. Let's get it. Trying to figure out the study strat. I started too late because I was doing stuff, trying to fix something in the car. Now it doesn't work and I have to fix something else. Figure things out, and that'll take time. And then I was busy for a sec, cooking and other things, and then I was watching some freaking YouTube for too long, but it's good. I don't regret it. All right, let's see. I'm trying to figure out the strat for the post quiz stuff. Because I want to cover all of like what I learn each day, but I don't want to forget the other stuff. So maybe I say maybe I do one thread that continues and I say, okay, give me like in-depth, difficult stuff on like just half of this randomly. Just pick and choose different sections. And over time, assuming that the algorithm, the AI is accurate, so I don't go like weeks without a fucking question on bit manipulation, then, or days, then it should be good. I think that's what I do. I say, hey, here's the whole thing. Make me implement different pieces. And maybe it probably makes sense to make me explicitly be writing code for things and not just like evaluating things can be useful, sure. Like I can see type conversion if there's something happening and I need to read the code and I just need to have an understanding that, hey, this gets converted to this and that's narrowing and that's why this is happening. Or, oh, that's unsigned. There's modulo wrapping here. Oh, that's why the value is still should be still positive, even though it should be negative because we're decrementing stuff. I think that's just right. In this case, it's going to be short and sweet. I'm just going to do this one video. I'm not even going to record multiple videos. And it's just going to be 9 minutes more here of learning, so until 10:15, and then 45 minutes of test. And I'm going to make it so that it's program stuff. That way I have to actually submit like actually written shit instead of just giving answers. Like the answer, it's cool. It's good for understanding. But I also need to, like, if you're a physicist, it's probably good that you can work your way through equations and actually solve shit. But in doing so, you probably have to have some common sense understanding of how things work. And you don't have to look every single individual thing up. All the knowledge to be a good software engineer is probably on my phone. But if I'm making a game, I can't just Google every single thing and say, hey, what about this? What about this? Okay, how do I do A? How do I do B? And then how do I do C using A and B? Oh, how do I do D using A, B, and C? And how do I do E using A, B, C, and D? Well, maybe nobody else has done E with this A and this B and this C and this D. And maybe there just isn't enough knowledge. What am I going to use AI to guess? Well, AI could be wrong. So I actually have to learn the shit myself and fuck around with it so that the understanding is in my brain. Because for me, I think it's faster to just say, hey, what are my times tables? Okay, fucking 7 times 8. All right, 56. Cool. Instead of going and having to Google the thing, it'd be cooler if I could just do the thing. Okay. So the first section here, 11.1, was talking about function overloading and what function overloading is, and how the function signature is the identifier and parameters. The count is the types and order of the types. And then how to make them and make them not be ambiguous. So if I made 2 and it was some sort of return type and then the function name and then int, and then I did the same thing but the name, but the parameters were titled different, it's still ambiguous because we have a redefinition of the same function signature. But that's just a function signature thing. So That's the issue. We have a redefinition. It's the same one. There's no overloading happening. But the second we have a unique signature, the combination of the identifier and the parameters, then we can have some actual overloading. Oh yeah, there are different pieces. So it's going to check and see, hey, are there any functions that already match this call to the function and its arguments? No. Okay. Are there any functions? Let's see. At some point, it checks promotions and then conversions and then user defined. I guess that's it. So it checks, hey, is anything exact? No. Okay. Can we promote any of these types to get those types? No. Can we numerically convert any of these types to get those types? No. Is there some sort of, so we can't promote, we can't do the easy form of implicit type conversion. Can we do the harder form, numeric conversion, where we can go from a character to freaking short, or short to a character, or a long double down to an int? No, there still isn't a conversion. Maybe we're talking like a class or an object as a parameter. Well, I need to, but the thing receiving it is an int. So how do I get this class to an int? Ooh, well, if there's a member function in the class that is able to return an int from the class / object, then that user-defined conversion will be used to convert it to an int. So it's basically exhausting all options to make argument A become parameter A. Or will argument B become parameter A? Does it already match? If it's already A and A, we're good. If it's B and A, okay, we're good. Promote B to A. Ooh, how about Z and A? Damn, now we have to numerically convert Z to A. Ooh, still no? What if there's some kind of other way of converting A into Q? User defined. Okie doke. Yep, sure. Oh, and then there was more stuff. Okay. User defined ones. In this case, it always returns 0. So it always can convert. So we can do foo x. And x is a class. And there's no foo of the class. But there's foo of int and double. Which one can this convert to? Oh, it can convert to an int. Therefore we do foo, convert it to an int implicitly, and then we call. We'll implicitly convert. And then after doing it, it may still apply the standard promotions for efficiency. Oh no, so we're saying, like in the case where the class can become an int, but then, okay, so if one of those conditions happens, it doesn't mean that's it, because it might not necessarily be at that. So as long as there is a path to take to resolve the function call, then it'll work. It's just that there must be a path. So if we have a function that is a function that takes a long double, and we pass it a float, well, in this case it'd be step 3 because it could be numerically converted to a long double. But let's say it's a class to a long double, but the class only converts to an int. Well, then once we have the int value, we can numerically convert it to become a long double. So we find the value that would be represented by a float, update the binary, and boom. Okay. I don't like leaning backwards. Tiring. we can apply any additional implicit shit afterwards. Yep, so for character instead of int, this still needs to become an int, so we can do promotion to do int. No matches, if there's still no match for user defined, it will try using an ellipsis. I have no idea what that is. What could an ellipsis be? If there's nothing user defined, is there some sort of other conversion somewhere else, seems like? I don't know. If no matches have been found, it gives up and says it's a compile error. Because there's no way to convert this value to that value in the call. It's still ambiguous. Because there's no food, there's no good, there's no definition here. Nor is there even a declaration. In the same step. Gotcha. We need that we have two values and then we can promote to get either of those. So ambiguous function call. Double one counts a long. A long has to be numerically converted to an int, but a long also has to be numerically converted into a double. In the promotions, we've got it's when you have two or more matches using the same step. These dogs are kicking me. For a little in the night. I'm probably gonna go to bed early actually because I'm tired and need to fix the sleep because the dog woke me up too early. Boys wanna go out? Come on. Let's go. You ready? Okie doke. That's pretty slow. Excuse me. Cool. One. Clear an integer variable named count. Initialize to that, and then print. Okay. So we could say 0.4. And count 10 and then 25 or 25. 10 and then 25. 10. And count is now 25. Okay. One point six. Test, and then even then, so we cannot do it. There's no. I wanted to make sure it wasn't a warning treated as an error, and it's an actual error. Okay. 1.9. What would be a cool way of doing this then? To combine them. You don't necessarily need to add them, but we could include them somehow. So we could say well, the literal character, the literal float, the literal int. I mean, I could just initialize 3 values and then. I guess so. I changed that because standard character output kills trailing zeros. Okay, let me bring these dogs in and go to bed. I gotta go to sleep. So tired.